Hello and welcome back. In this video we'll be looking at section 3.3, which is all about how to divide polynomials. Well, before we talk about dividing polynomials, we should go back through long division, so just dividing integers. So where we start, let's remind ourselves of a little bit of terminology. 26 here is going to be the divisor. This is what I'm dividing a number by. So 26 is going to be the one that's doing the dividing. 3,983, this is going to be the dividend. As in, this is the thing that is being divided. So when we divide 3983 by 26, we look to see how many times 26 will fit into the first few digits. So first of all, 23 does not fit into 3, so we will ignore that, but 23 does fit into 39. So how many times does 26 go into 39? 26 goes into 39 once. We multiply 26 by 1 and write that here. And then we subtract 1, 3. So this should be somewhat familiar. But the steps that I did in order is we first divided just part of this, we multiplied, and then subtracted. So divide, multiply, subtract. Then we bring down the next number, and we do the same thing again. So then the question is, how many times does 26 go into 138? And this will be 5 times. So again, we're just dividing this smaller number by 26. We'll get 5. 5 times 26 would be 130. We then subtract and bring down. So again, we divide, we multiply, and subtract. For the next one, we look at this and we just divide 83 by 26, and we should get 3 times 26 will be 78. 83 minus 78 is 5. So after all is said and done, I've run out of things to divide here. I've reached the end of my number. So 153, this is the quotient, but we had a remainder of 5. So when we write this down, 3,983 divided by 26, this is going to be equal to 153 plus a little bit extra, 153 and 5/26. So what you'll notice is that this last 5 I can't divide by 26, so the best I can do is to write it down as a fraction. So this is going to be 153 and 5/26. One other way of writing this down is the following. If I write 3,983, this is going to be the same thing as 26 times 153 plus a little bit extra. So again, this equation here describes everything that's going on here. 3,983 is going to be 26 times 153 plus a little bit extra, plus this remainder term here. And this is what we're going to shoot for today. So let's do the same thing, but what we're going to do is we're going to divide some polynomials. So I'm just going to go through this first. I'll explain all my steps, and then I'll write down what the steps were after the fact. So we'll take, I want to leave myself a little bit of room. Let's take x squared plus 14x plus 45, and we'll divide it by x plus 9. Again, x plus 9 is what we're dividing by, so this is going to be our divisor. X squared plus 14x plus 45 is going to be the dividend. It is what is being divided. and then we'll just need to figure out what our quotient and what our remainder is. So again, what we'll do is we'll look at our first, in this case, two terms, because our polynomial that we're dividing by has two terms. And we'll see how many times does x plus 9 go into x squared plus 14x. We are in fact just going to focus on the first terms in both of these. So how many times does x go into x squared? If you take x squared and divide it by x, you get x itself. So we divide, we multiply, so x plus 9 times x, I'll have an x squared for the x times the x, plus a 9x, 9 times x is 9. So we divided, we multiply, and now we subtract. X squared minus x squared is 0. 14x minus 9x is 5x. So divide, multiply, subtract. The same order as last time. Then we bring down our last term. We go, how many times does x plus 9 go into 5x plus 45? And again, what we're going to focus on is just the first terms. So how many times does x go into 5x? 5 times. So that's our division. We multiply 5 times x plus 9. So we'll have a 5x. And a 5 times 9 is a 45. So when we subtract these, we get 0. So our remainder is 0. And our quotient is going to be x plus 5. So again, writing down exactly what this means, if you take x squared plus 14x plus 45 and you divide it by x plus 9, we get x plus 5 exactly. There's no remainder, so I don't have to do anything else. Another way of writing this down is, instead of saying the top divided by the bottom is equal to this thing over here, I can say our dividend is going to be equal to x plus 5 times x plus 9. So this factors exactly. So this is just one of those nice situations where we have a polynomial that factors. So let's go through these steps more explicitly. So the first thing that we didn't have to do was arrange the terms in descending order of power. So if we come back up and check, we'll see that we have, what are our powers here? This is to the second power. X by itself, we can think about as x to the first power. And then there's no x here. So this is the same thing as x to the 0 power. So 2, 1, 0, it's in descending order. Perfect. Next, we do our steps. We divide, multiply, and subtract. What are we dividing? The first term in the dividend by the first term in the divisor. So when I did this first step, I was looking at x squared here, and I divided that by x to get the first term in my quotient, which was x. Next, we multiplied our divisor by whatever we got from part 2. We then subtracted that from the original and brought down the next term. And we just kept doing this until we ran out of space. So, divide, multiply, subtract. Let's do more examples. So, let's divide 7 minus 11x minus 3x squared plus 2x cubed by x minus 3. So again, we're going to take this polynomial. This is not written in descending order, so we'll have to flip it around. If I do write it in descending order, I'll have 2x to the third as positive, minus 3x squared minus 11x plus 7. and I want to divide this by x minus 3. And it just says we want to express the result as the quotient plus the remainder divided by the divisor. So I'll show you what this looks like at the end. So the first thing, we look at the first term here and the first term here, and we go, what is 2x cubed divided by x? Well, 1 power of x cancels, so what I'll be left with is 2x squared. Note, I'm writing it here because this has 2 terms, so I'm looking at the first 2 terms here, and this is where this will go. Next, I multiply everything by 2x squared. So x times 2x squared, that's 2x to the third. Minus 3 times 2x squared is going to be minus 6x squared. So far so good. Now I subtract these. 2x cubed minus 2x cubed is 0, so I just won't bother writing anything. 3x squared minus negative 6x squared. So let me write this down. Negative 3x squared minus a negative 6x squared. Well, if I'm subtracting a negative, that means I'm adding, so this is going to be positive 3x. I keep writing 3's instead of 2's. Positive 3x squared. I bring down the next term. And now, again, I'm looking at the first term here and the first term here. So the question is, what is 3x squared divided by x? Well, 1 copy of x cancels out, so I'm left with 3x. And again, this will be positive 3x. So now, after I divide, I multiply. So 3x times x is 3x squared. 3x times negative 3 is going to be negative 9. And again, here I'm going to have negative 11x minus a negative 9x. So I'm subtracting a negative, which is the same thing as adding. So I'm going to get negative 2x. Bring down the last term. I divide the first term here by the first term here. Negative 2x divided by x. The x's will cancel and I'll be left with minus 2. After I divide, I multiply. Negative 2 times x is going to be negative 2x. Negative 2 times negative 3 is going to be positive 6. And when I subtract these, I will get 1. So, after all is said and done, I've run out of terms. So, the quotient is going to be equal to 2x squared plus 3x minus 2. And the remainder is going to be equal to 1. I'm going to erase this so I have a little bit more room. So if I come back up here, the question asks us to express the result as a quotient plus the remainder. So let's write this down. So our answer is going to be our quotient plus the little bit that I couldn't divide. So my answer is going to be 2x squared plus 3x minus 2 plus our remainder that we couldn't divide, so 1 over x minus 3. We can't divide 1 by this, so the best we can do is just to leave it as this fraction.